Hello, my name is Ken Holman, and I thank you for your interest in the role of subset schemas in an interoperability framework. And thank you to the ENDORSE conference organizers for including this topic in the agenda for this week. I have a long background in international standardization and the application of markup technologies such as SGML and XML. I was the founding chairman of the OASIS XML Conformance Committee, and until last month, I was the chairman of the OASIS Universal Business Language Technical Committee, founded by John Bozak. I need to set the stage for my subset project by looking into some detail regarding the OASIS Universal Business Language. UBL, also internationally standardized as ISO IEC 19845, is a semantic library for business documents in the procurement and transportation logistics domains, such as purchase orders, invoices, and waybills. The semantic components in the library mesh very well with other international standards, such as ISO 20022, used in banking and payments. UBL version 2.3 is a very large vocabulary incorporating 91 different document types for procurement and transportation logistics. Over 5,000 elements are available to represent the semantic components suggested by the UBL Technical Committee. Although it is very large, the committee has followed the Pareto principle, believing that really only 20% of UBL is needed to address 80% of the world's business needs. The other 80% of UBL addresses well-accepted business principles that may be of interest to a smaller audience. From the outset, the committee decided not to attempt to create a single semantic library to meet everyone's needs. Rather, technical markup-related approaches to support custom requirements were agreed to be enabled by the artifacts developed to support the deployment of a user's semantic library based on UBL. Specifically, extension schemas allow a community to add their own markup constructs to conforming UBL documents without impacting such conformance. UBL instances with extension content still validate against the published committee schemas without modification. Additional schemas allow a community to add their own document types to leverage the UBL semantic library of common constructs. This promotes interoperability at a semantic level between standard UBL documents and custom documents based on UBL. But the subject of this presentation is the utility of subset UBL schemas that contextualize the semantic library components for a community to focus the way it uses UBL. But first, a quick overview of the separation between semantics and syntax through the lens of existing international standards for electronic business from JTC1's working group named eBusiness. ISO IEC 14662 is the Open EDI reference model that has been standardized for over 25 years. This standard separates the concepts of electronic business between the business operational view, the BOV, from the functional services view, the FSV. ISO IEC 15944 Part 20 further refines those concepts to illustrate how these two perspectives are implemented in the real world. In the real world, electronic business is and has been performed within a legal and business environment of participants all agreeing on the concepts they use to express what it means to do business. Over centuries, business scenarios have evolved in which participants in various roles exchange the information needed to do business. This information semantically is in bundles, where a bundle needs to be a complete collection of semantic information the role needs in the scenario to effect business in the environment. This was true before there were computers and before there were even paper records. But in the real world, we have computer systems that need to exchange structured user data presenting the information of a bundle. These exchanges are choreographed between participants who are connected by some transport mechanism. The purview of ISO IEC 19845, OASIS UBL, is the semantic information bundles and the syntactic marked up user data used to represent the information for computer systems to process. The business objects, section 2 of the specification, and the functional mechanisms governing the syntax of marked up documents are in sections 3, 4, and 5. Thinking of the semantic information as an abstract bundle has been useful so as not to get carried away thinking about syntax, which is difficult for seasoned markup people. I commend these specifications to you for your consideration. The semantic model for UBL has a single common library and 91 separate onion skin outer layers. This promotes interoperability, straight-through processing, and document flipping by ensuring that any given library construct is identically structured in all information bundles. Supporting the semantic library is a normative set of XML schema expressions and non-normative expressions of syntactic constraints in JSON and in ASN.1. Layered on top of the syntactic expressions are a set of additional document constraints, such as no element being allowed to be empty. The UBL semantic library is modeled using the Core Component Technical Specification, CCTS, from CFACT. On the left, I've shown how the unqualified data types are used in the basic components, which themselves are used in aggregates. Library aggregates are used in other library aggregates as association entities and in document aggregates representing the entire semantic information bundle. In a tree metaphor, the data types are the shapes of the leaves, the basic components are instances of the leaves, and the aggregates are the shapes of branches, and the associations are the instances of branches. In syntax, these aggregate components are realized as elements containing other elements and never any attributes, while basic components are realized as elements never containing other elements and possibly having attributes for supplemental components of the given data type. You can see in this exploded instance how the semantic library governs the element structure. Then, in support of the syntax implementing the semantic modeling artifacts, there is an elaborate set of generated schema fragments. At the very bottom of the entire schema import tree on the right, one finds the CFACT authored core component type schema fragment on which all of the other information components build. All of the schema fragments supporting the semantic component definitions on the left are synthesized from an XML expression of the CCTS model created in a spreadsheet by the committee. No hands touch the library schema fragments. Everything is generated programmatically using open source tools available in the committee's GitHub repository. Now, with all that background of the standards-based definition of UBL, we get to the crux of this presentation to underscore the important role of semantic library subsets, and in turn, supporting those library subsets with schema subsets as computing artifacts. To illustrate this, something that came out of the 80s draws a distinct parallel to the work being done here: the development of TCP/IP protocols that supported a number of powerful features. I will read this quote to you, substituting the word protocol with the words semantic library in both cases, and it makes a lot of sense and provides us a formal lesson as semantic library creators. Quote, in general, only a subset of a semantic library is actually used in real life, so you should be conservative and only generate that subset. However, you should also be liberal and accept everything that the semantic library permits, even if it appears that nobody will ever use it. End quote. Sage advice, and it comes into play in the UBL world where applications generate UBL syntax and applications consume UBL syntax. The sheer magnitude of 5,200 semantic components in the library and in the committee XSD schemas overwhelms computer systems that generate code in support of application development by reading the entire XSD. They fall over dead, being unable to generate all of the necessary classes and references and recursive structures possible from the entire library. Having a tool that creates a subset of the XSD that contains only that subset of the semantic library actually used by the committee enables developers using XSD-based code generation tools to create XML syntax. In the context of a four-corner model network, such as PEPAL or CEF in Europe, or the Business Payments Coalition, BPC, network in North America, Corner 2 can work with the subset schemas to generate the XML that is sent to Corner 3. In turn, Corner 3 can use the full UBL schemas to validate not only the content that arrives as part of the community subset, but also any additional valid UBL content that may be included in the serialized information bundle from outside the community. So to support this concept, I have published a GitHub repository that leverages the very same tools I created for the UBL committee to generate the schemas. In this case, the tools are looking into an edited copy of the committee spreadsheet, where the subset specifier indicates which semantic components are to be ignored in the library subset. This is done by specifying a cardinality of 0, which is a cardinality one would not find in a schema expression. We can see here a decision by the BPC semantic group that semantic address components agreed upon do not include any component detail below the city's name. Instead, the unstructured address line branch is used for those semantic components below the city's name. From the city's name and up, all of the UBL components are in the subset with the same cardinality as in UBL. The community points the subset tool to this spreadsheet and presses the button. Out of the process comes an XML schema expression without the ignored semantic components realized as element declarations. And thus, the code generation tools need never have to even consider for XML creation these components because they are commented out of the XSD schema expression. For your interest, I've included in the package of slides additional content that I was prepared to present if the available presentation slot was longer, but there was no time to include. I hope you find the additional information of some interest. Thank you again for your interest in this topic of the role of schema subsets in an interoperability framework.